My name is Sawyer, and I am the head of Scale Developer Success Team, as well as one of the lead community developers for the Scale ecosystem. Today, we are going to be walking through how to add a token to the Scale Bridge. And so what we're going to do is we're going to use a few different tools, which I'll kind of walk through in a second, as well as at the end, do an actual test run from basically Ethereum to Scale. So to kind of kick things off, I want to walk you through what you see on my screen, and then we'll kind of move forward from there. So to start, I have a command prompt over on the right. I use Warp, but you're more than welcome to use whatever tool you prefer. Please note that I do all of my development on a Mac. So if you're using a Mac or a Linux or a Unix-based system, you should be good to go. If you're on a Windows computer, sorry, some of this stuff might just break or not work because honestly, Windows is a bit painful to use at times, for me at least. But down below, I have my trusty text editor. I love to use Sublime Text. That's kind of what you see here. And then up above, we have, the web browser. Right now, you can see kind of the plan of attack up here. And then down below, a couple of just kind of recommendations or links to, check out after. The Scale website, Scale Developer Discord. Follow me on Twitter. That's my shout out. And if you're interested in reading more about kind of some of the things that I talk about, check out the blog. Um, but the other tool that we'll need today is we will need a Gnosis safe. So in this case, I'm using the Protofire Haleski safe because again, we're using Ethereum Haleski, but I'll kind of get more into that shortly. So to kind of kick things off, step one is we need to actually deploy the token. So we're going to be using Tether, Tether USD today as kind of our base token. And so what we're going to be doing is we're going to start off by using the Scale Interchain repo, which is something that I've recently created. It's available on my Dirt Road Development GitHub. I'll have whoever posts this share a link in or myself in kind of the comments. But basically, to give kind of a little bit of context, Scale is a multi-chain blockchain network. It is the home of an interoperable set of layer one blockchains. I like to call them mini Ethereum as superpowers. Um, all of these scale chains are built different to basically enable, gaming, DeFi, AI, DePIN, social, etc., but in a totally new way. Zero gas fees, super high throughput, instant finality, ridiculously high block gas limits, kind of all the bells and whistles that you kind of wish Ethereum had, and even most of the L2s, and then a whole bunch of other great stuff on top of that, like RNG, Oracle, stuff like that. So again, we'll talk more about those in future videos. But today, we're going to be focusing on one of the key features that most blockchain networks wish they had, which is a native bridge that connects everything. And that is called IMA, or the Interchain Messaging Agent. So what we're going to be doing is we're going to be deploying these tokens, right? And then what we're going to do is we're going to map these tokens from Ethereum testnet to Scale testnet. So to kick things off, if you haven't already, you're going to clone the Interchain GitHub repo, which you can see I have here. Once you clone this repo from GitHub, it's pretty easy. You just run setup.sh. If you haven't um, run it before, you can run the little chmod command to give your computer access. But basically, setup.sh, all it's going to do is it's going to prepare the multi-sig wallet CLI with a couple modifications I've made to make it work on most Macs out of the box, as well as Linux computers with Python. And then it's going to actually set up the smart contract repo. So from there, we're going to go into the smart contract portion of this mono repo, which is the tokens. And in this case, we are going to run the deployment script. Okay, so for the USDT, so it's going to be script full interchain deployment. And then we can see here, I'm just going to pull my little video down for a second. We're going to actually pass in a couple parameters to the deployment contract. We can see here we have the token name first. We have Europa testnet second. We have Titan testnet third. I'll explain this more so later in the video. Then lastly, we're going to pass in the legacy flag so it skips the EIP 1559, and we're going to use verbose because I like to just see all the stuff that kind of gets outputted. Lastly, we're going to add broadcast, which is going to make this actually fire. And then we're going to add slow, which ensures that each transaction has enough time to confirm before it proceeds. It'll still be very fast because everything takes about 1 second per transaction. Now, before you fire this off, what you need to make sure of is um, in your token folder, you have a .env.example file when you clone it. Make sure you copy that over into a .env. I'm not going to show you mine, obviously, for security purposes, but in your .env file, make sure you add a private key. This can be a private key from, you generate locally with Ethers or VM. It could be a private key you copy in from, MetaMask or something else. I generally recommend using ones that are, I call them burners, aka you're not using them for anything else, just for security purposes. But obviously, do what you think is best there. Once you have that private key in, you'll be able to run the script. Very straightforward and simple. Fire that off. So forward script, the path to the file, which is this full interchain deployment. That dash dash sig run is basically passing in some parameters, and then USDT primary scale chain, secondary scale chain, and then all of kind of the flags we need to make forward run successfully. The nice part here is most of the addresses are going to come out fairly similar because of how the nonces operate. Um, with blockchain, I've actually deployed from this address before, so it's going to be a little bit more mix and match than if you did this off of a fresh address. We can see everything's kind of deploying one by one by one. So this is our USDT on Europa, USDT wrapper on Europa. Again, I'll explain that more later. USDT on Titan, which is our AI hub, and USDT on the Haleski testnet. So now that we've actually deployed the token, and like I said, that's pretty easy, right? And before we actually proceed, just so you know, the reason this was so easy is because we want to make sure that your developer experience is fantastic. And so what I've actually created is a full-blown script in Foundry, which basically switches between these networks. It dynamically grabs the right token, sets the right decimals, the proper token name. It basically just ensures that everything gets set up properly and you don't actually have to think about this. So the idea is that, in the future, when you have your own scale chain, you don't have to sit there and like, copy every little command and step. A lot of it can actually just be automated, just like you see here. So hopefully that makes sense and you've got a bit more context as to what we just did. Again, this is all public, open source, MIT license. You can go check it out on GitHub. It's github.com. The organization is dirt/road/development. And then it is scale dash interchain is the repo name. So I'll throw that into the plan at the end of the video. So now what we're going to do is we're going to go over and we're going to actually prepare to map this token using our Gnosis Safe. The reason that we're using a Gnosis Safe, we're going to give a little bit of background on this first, is scale chains themselves are very unique. They are layer one blockchains, and like I said, they have a lot of superpowers with them, but they have a very specific, we'll call it ownership structure, which is different than a traditional L1. Traditional L1s run fully, we'll call them, permissionlessly, in the sense that the validators theoretically have the ability to make major changes and, kind of push anything forward they see fit as long as they all come to consensus. On a scale chain, that's still kind of true in the sense that the validators need to upgrade, but they actually upgrade at the network level. Your chain just kind of keeps operating and gets these kind of network-wide upgrades. For specific actions, things like managing your bridge, deciding who can deploy, distributing S fuel, that is actually done kind of starting from the chain owner or operator. You can delegate out to different wallets and addresses, but in most cases, I find that using the Gnosis Safe is actually very nice because the declaration of, or the declarative nature of how you can define things within the Gnosis Safe and batch them makes it super easy. So that's what we're going to do here. We're going to use this Gnosis Safe, which is essentially the scale chain owner on the scale testnets. On mainnet, each chain has its own multi-sig or contract operating it. On testnet, we have one that's kind of used across the board. And so what we're going to be doing is we're going to be using this Gnosis Safe to essentially set everything up. So the first step is we need to send a transaction on the Ethereum Haleski testnet that says, add this token to my bridge. Okay. And so how we're actually going to do that is I'm going to pull up this right here, and we're just real quick going to preview this in the browser. And so what you're going to see is a little common information. And so we're going to skip down to testnet because, again, on this case, we're doing testnet only. And we see scale chain names, and we see the common addresses that we're going to need. And so in this case, I'm just going to pull this over to the other side of the screen for a second, just so we can kind of do this side by side. What we want to do is we want to actually send a transaction to deposit box ERC20 on scale testnet, which is this address down here, this 0x412. This deposit box is the same for the entire scale network. Obviously, this one up top is the same for the entire scale mainnet network. When we paste this in, and I hope you saw that I used the implementation ABI, and we scroll down, we now have access to all of the functions, right, on this contract. And so what we actually want to do is we want to go add ERC20 token by owner, okay? Now what we want to do is we want to basically set this up where we're going from Haleski to Europa, right? Because we're using Europa testnet. And so right here, we have our Europa testnet scale chain name. So we're going to copy this. We're going to paste it in. If you had your own scale chain and you wanted to bridge in some token from Ethereum to your scale chain name will go here instead of the Europa one. And then lastly, we have the ERC20 on mainnet. And so this, real quick, I'm just going to pull this back over. We want this value right here on Haleski. This is USDT on Haleski, okay? At least our version of USDT. We're going to go ahead and add that transaction. Now, in addition to doing that, because this is, again, a Gnosis safe and Gnosis safes give us a lot of flexibility and power, we don't need to do this separately, right? We can actually batch these together. And so what we're going to do now is we're going to go to the the third step, which is adding the token on Europa using Token Manager ERC20. This, in my opinion, is probably the most complicated part of the process because we have to introduce a new tool. This new tool is what we call the multi-sig wallet CLI. Okay, and again, it's set up immediately when you download and clone the Scale Interchain repo. Okay, what we want to do is we're going to actually use a specific function which allows us to encode data and send essentially an arbitrary message from Ethereum Haleski to a scale chain. That's a lot of very technical jargon, and so to break that down into something that makes a little bit maybe more sense in layman's term is the Ethereum mainnet and Scale share a specific piece of functionality, which we call a messaging layer. If you've ever heard of Layer 0, Scale IMA, or the interchain messaging agent, is essentially Layer 0 built into Scale, just fully custom to Scale, right? Obviously, has nothing to do with Layer 0 itself. What it allows us to do is send message information from one chain to the other or vice versa. So we can actually send messages from Ethereum to Scale Europa, or from Scale Europa back to Ethereum, or Scale Europa to any other scale chain, or vice versa, right? It's kind of a whole interchangeable situation. What that means is we can actually let our Gnosis safe on Ethereum Haleski, or if you're on mainnet on Ethereum mainnet, send a transaction from mainnet and execute on the scale chain. And so that's what we're going to do here. So we're going to actually do npx, which is the start of the command, msig, right, which is for multisig, encode data, which is the function we want to run. And the first parameter is going to be the scale chain that we want to basically have this message execute on. In this case, it is Europa testnet, which the proper name for that is, again, Juicy Low Small testnet. Now, the second value here, I'm going to throw my video back up to the top. That way it's not in the way. The second value here is going to be Token Manager ERC20. There are a number of different token managers for Scale. In this case, we're only going to focus on the ERC20 version because that's the token we're moving. From there, we want to have a specific function we are calling on Token Manager ERC20, which is add ERC20 token by owner. Now, the next parameter is mainnet, okay? This parameter, all the things that come after the Token Manager ERC20 function name, these parameters or arguments are actually for the executed call on the scale chain. So if we look at Token Manager ERC20, add ERC20 token by owner, it takes 3 arguments. The first argument is the origin chain. So the origin chain in this case is Ethereum Haleski. The target is Europa. So the origin is Ethereum Haleski. Ethereum on Scale is always mainnet. So that's why you can see mainnet with a capital N here. And then from there, we want the origin token, and we want the target token. Okay. So the origin token, Haleski, is this one right here. And the target token is the one on Europa, which is this one right here. Okay. And so now I'm just going to roll through this real quick, make sure that I have no incorrect spaces. Looks good to me. We're going to go ahead and fire that off. Okay. And this is going to generate a block of encoded function data. So now what we need to do is we're going to grab message proxy, okay, specifically message proxy, and this is on testnet still. Remember, this is on testnet. We're going to head back over to our Gnosis safe, and we're going to go ahead and copy in this message proxy on mainnet into this field. And what's going to happen is it's going to give us, a bunch of functions, which this did not seem to update. So let's try that again. There we go. Use implementation API. And now we can see we have some message proxy functions. Now, the thing is this encoded function data is actually handling this post outgoing message for us, okay? And so what we want to do is we want to select custom data, okay? We're going to scroll down. We're going to put 0 in for ETH value because we don't want to spend any of our Ethereum gas fees or Haleski gas fees. We're going to copy this block of encoded data right here. We're going to go ahead and add the transaction. Now what we can do is we can create this batch. And before we send it, let's hop back over to the plan and make sure that we're in line with where we're at. So what we've done is we've deployed USDT on Haleski, Europa testnet, and Titan testnet. We'll worry about Titan later. We've added the token on Ethereum using deposit box ERC20. We've added the token on Europa using the token manager ERC20, right? These are our two functions here. And so the next step before we actually test this is we have to execute this function. So we're going to go ahead and send this batch. Before we do it, we're going to simulate with Tenderly because Tenderly will tell us if there's anything that we should be concerned about. We'll open that up and we're not going to dive into it right now just because there's a lot of different information. But mostly what we care about is we should see some event that looks like a ERC20 token is being added. And we should see an execution success. So again, we're not going to dive into all of this right now, but overall, when things are successful, it's usually a pretty safe sign to proceed. We're going to go ahead and sign this. Sometimes it'll let you execute right away. Sometimes it'll ask you to sign it first. We'll go ahead and confirm this and confirm that signature. Now we're going to go to view transaction, and we're going to go ahead and we're going to execute. This Gnosis safe is a 1 of 5 because again, it's testnet, and we're not really concerned right now with security. But on a mainnet Gnosis safe, there probably will be many signers, and so you might be able to sign it, but you might have to have other people come in and actually sign and then execute. So we're going to go ahead and execute this now. And what I'm going to do is I'm going to go ahead and confirm that. And now we're going to immediately open this up. This is going to take us to the Haleski Explorer, and then in a separate tab, I'm also going to open up the Europa Explorer on testnet. I'm going to pull that down here. And we're going to go ahead and see if that was it already. Perfect. Okay. So you saw how fast that was. It was literally as soon as I opened the browser, it was already there. So we can see on Haleski, we have our multi-sig transaction, and specifically we have our ERC20 token added. So that's good. Great. Then we have this outgoing message, which is you can actually see parts of that encoded function data down below in this. And then on the scale side, this is the Europa Testnet Explorer. We can see ERC20 token added. It posted via this transparent upgradable proxy, which is through the token manager through the message proxy. And we can see our ERC20 on Origin, ERC20 on S-Chain. So very fast, right? That was nearly immediate that posted. And mainnet is just as fast. Now what we want to do is we want to go ahead and we actually want to test this bridge out, okay? So we've done all of the hard work so far to actually set the bridge up, right? And now we want to actually go ahead and test it. So what we're going to do is we're going to grab this token address on Haleski. We're going to head over to my MetaMask, and we're going to actually remove this token because this was an old one. So we're just going to hide that. And we're going to go ahead and import this new token. And we're going to import it there. Now what we're going to do is we're going to grab my Haleski address here. We're going to go back. And what we're going to do is we're going to go to USDT. We're going to send, and we are going to go like this. And we're going to remove this Haleski piece. And that should pop. There we go. And now what we're going to do is we're going to send over a very, very, very large deposit of USDT. into the Gnosis safe. We could technically do this manually through the EOA, through the MetaMask, but it's actually easier during this initial testing phase to do it through the Gnosis safe since we have that declarative function UI. Okay. And so I've kind of got some things preset for us here. So what we're going to do is we're actually going to go new transaction. We're going to go transaction builder. And reminder, when you're using ERC20 tokens, you have to approve the contract that's going to move the tokens before you actually spend the tokens. And so what we're going to do is we're actually going to take the Haleski contract address. We're going to pop it in here. You're going to notice that it's not going to pop up on ABI automatically. That's because I didn't verify it on the Explorer. But I have the ERC20 ABI right here. So nice and easy. What we have is we have this approve function. We have a spender. In this case, the spender is going to be, if we hop back over to our common, the spender is actually going to be deposit box ERC20 on mainnet. And then we have some amount. And so in this case, we'll just do 100,000, which is the equivalent of 0.01 USDT with 6 decimals. So we're going to go ahead and add that transaction. And then what we're going to do is we're actually going to go back to common. We're going to grab this address again. We'll go to the safe wallet, and we're going to paste in this deposit box ERC20 address again. And now we see our deposit box functions. Now you'll see two different functions that we can actually use to bridge here. We have deposit ERC20 and we have deposit ERC20 direct. The difference between these is deposit ERC20 is going to bridge the token to the same address that sent it. So for example, if we click this and we send, it'll basically bridge to the Gnosis safe address on Europa. But because this Gnosis safe isn't deployed on Europa, we should use the ERC20 direct function, which will allow us to identify a different address to deposit the tokens to. So in this case, we have Juicy Low Small Testnet. That is the name of the Europa chain on testnet again. We have the ERC20 on testnet. Again, this is going to be this address here that we have deployed for USDT on Haleski. The amount, which is again going to be 100,000, representing 0.01 USDT on when we bridge this token. And lastly is going to be my address, right, that I'm using to execute all this from MetaMask because I can access that directly on Europa. Now we're going to go ahead and add this transaction to the batch. We're going to go ahead and create the batch, and we're going to go through this process again. Okay, we can see set allowance to 0.1. Great. We're going to simulate on Tenderly. We're going to sign, and we're just going to walk through these steps again. Great. And now we're going to go view this transaction again, execute. And again, we're just going to simulate a second time, just force of habit, just make sure everything is going to be as smooth as possible. This is going to pop up. And very similar to last time, what's going to happen here is we're going to have a transaction that's going to pop on Haleski. And then we're also going to have a transaction that's going to pop up on the Europa side. And so the actual flow of what's happening in this case is we're taking some X amount of tokens, so 0.1 USDT, which is actually 100,000 represented in the EVM. And we're going to lock them in deposit box on the Ethereum mainnet on Ethereum Haleski. Then we're going to mint them on the Scale chain. And so we should see this pop up here very quickly. And here we go. This post incoming messages. This is how you know it's coming from message proxy. Now what we can do is we can actually see 0.1 USDT, and we can see that it actually minted to my address, that 0x85FD. So now I have 0.1 USDT on the Europa testnet. Okay, so we're going to pause there. We're going to head back to the plan and check out what's going on. So what do? We deployed USDT on Ethereum Haleski. We deployed it on Europa testnet. We deployed it on Titan testnet. Again, we'll talk about that in a second. We added the token on Ethereum using deposit box ERC20. We added the token on Europa using Token Manager ERC20. And we just test bridge from Ethereum Haleski to Europa. I apologize for that typo there. I just noticed it. That's supposed to say Ethereum Haleski to Europa. Now, what we have the ability to do is actually move this token from from Europa out to other scale chains. Okay. And so what we've done here, if you can kind of see over in the terminal again, we actually have this second deployment on Europa. This is actually a wrapper contract, so ERC20 wrapper. And then we have the USDT token on Titan. And so I'll come back in another video, and what I'll do is I will prepare everything to show you how to basically map that Europa to Titan connection, and then how to actually wrap and bridge and get everything set up in that manner. So we'll go through that in a second video. But for now, what we've done today is we've learned how to deploy a set of tokens using Scale Interchain, which again, we're gonna close this out really quick. We're just gonna hop back through the Scale Interchain repo. Again, we have the multi-sig wallet CLI, and we have these tokens, and we have a whole bunch of predefined tokens, the wrapper. We have some mocks. We have an actual test suite that shows how to do this, how to wrap, how to do everything. Has some kind of basic setup here. And then we also have the interchain deployment scripts, which kind of does everything. We have a whole bunch of tokens here that you can use. You can always add your own as well. Um, from there, we used our multi-sig wallet CLI to actually generate some encoded data, which you can see here. And then lastly, we used the Haleski Protofire Gnosis Safe to actually map these tokens, execute functions via deposit box, message proxy, etc., and then actually run a test bridge with our token. And so the end result, what we can actually do is we can add this to the Scale portal. We can make it available to developers. We can put tokens in a faucet on testnet. We can make it very easy to give them the ability to test these full flows that they may see on mainnet within their applications. So um, hopefully this was, obviously highly educational, but also gave you a nice kind of understanding of how to set up a token on your own scale chain. So again, if you're interested in, purchasing your own scale chain, you want to run your own, ecosystem chain, whatever it may be, please don't hesitate to join us in the Scale Developer Discord or DM me on Twitter. Again, I'm here to help the community and the Scale ecosystem, build and grow, and ultimately here to help the space continue to, succeed in a more decentralized and open internet. So, thank you so much. Again, my name's Sawyer. I run Scale Developer Success Team, and I'm one of the lead community developers for the Scale Network. Hope you enjoyed, and we'll see you back here soon with another video.